So previously, given a sheaf K on a Riemann surface X, we have defined the cohomology group of K with respect to an open covering U, and then we define the general cohomology group, right? That's going to be the direct limit over the different covering. We ordered the coverings by refinement, and then we have induced map on cohomology groups. If V is a refinement of U, we have an induced map, this form a direct system, and then taking the direct limit gives us the cohomology group. Now here I need to make a remark, a warning. This might be a bit counterintuitive, but this is not like the usual refinement notion that we are used to, in the sense that if we add open sets to U, right? Now if we have more open sets and form a cover U prime, then actually U is finer than U prime under this definition of refinement. Because in this definition of refinement, it's about comparing the size of the open set. You can think about it that way instead of the number of open sets. As we see here, every open set in U is containing some open set in U prime. So if U is a subcover of U prime, then it's actually a refinement of U prime. So that's all a bit abstract. Now we're gonna do some explicit, concrete computation. So we're gonna look at the cohomology in degree 0 and in degree 1. And the claim is that the cohomology in degree 0 is just a group of global sections of K. And in degree 1, remember we said in general these cohomology groups are just like a union of the cohomology with respect to some covering, right? But in degree 1, it's actually true. It's actually equal to the union of this cohomology groups. So let's prove both of this. Alright, so now let's look at the cohomology groups in degree 0. The claim is that no matter which cover we choose, these cohomology groups are all going to be isomorphic to the group of global sections, and these isomorphisms are all going to be compatible with these maps in the direct system. So then this implies that this cohomology group must be isomorphic to the global sections. So let's review why this is the case. So what are the elements in this group? Well, so these are cocycles, zero cocycles. Zero cocycles are first of all zero cochain. So they are, if we let this cover U be consist of open sets UI, they are just a tuple. For every UI, we take a section Fi over UI, right, of K over UI. And so that's what it means for it to be a cochain, zero cochain. What does it mean for this to be a zero cocycle? Well, it must lie in the kernel of the boundary, co-boundary map, right? So this should be 0. But if you unpack the definition of this, then this is just saying that these Fi's must be compatible. So we got compatible sections on each UI, right, of a cover UI of X. So they must glue to a unique global section by sheaf axioms, and thus we have this isomorphism. Now, similarly, we have isomorphism here and here. On the other hand, these maps in the direct system, these are just induced by restriction map, right? So all of them should be compatible with this isomorphism, and thus this direct limit must be isomorphic to the group of global sections of K. So we are done with the H0 case. Now let's move on to the H1 cohomology.